फील कर रही है नहीं वापस बैन लगा उसके ऊपर.
Hello everyone. Let's discuss with the definition of solutions and types of solution, and in this particular module of the chapter solutions and colligative properties. Let us begin with the definition of solution first, where we'll basically start with the introduction part, where I say that solutions are the mixtures of two or more components. Now when I say the word mixture, let us have a discussion about the mixtures first. And mixtures, depending upon the size of the components, they are broadly classified into three types, of which the first one is a coarse mixture. The second one of the type is called as a colloidal dispersion, and the third one is referred as the true solution. Let's have a discussion about all of them in detail. If I talk about the coarse mixture, then in this case the size of the particles are relatively bigger, and the example of such type is a mixture of salt and sugar is a basic example of a coarse mixture. If I talk about colloidal dispersion, then in this case the particle which is present in the solvent or which is dispersed in the solvent, they are in the range of 10 to the power minus 7 centimeter to 10 to the power minus 4 centimeter. And the example of such type is ferric hydroxide solution Sol, arsenic sulfide Sol, and there are many more examples of this. In case of colloidal dispersion, first of all it is a heterogeneous mixture and can be easily separated. And if I talk about the particles, then the particles which are present in case of the colloidal dispersion, they carry either a positive charge or they carry a negative charge. Let us finally talk about the true solution. In case of a true solution, the particle which is present is in the soluble form. So I say the soluble substance are dissolved in the solvent. That is the first thing. And secondly, if I talk about the size, the dissolved particles are of small size of the order 10 to the power minus 8 centimeter. And lastly, if I talk about the last point, it says that they are homogeneous and they cannot be separated by simple mechanical methods. So that's what we have for mixtures, coarse mixture, colloidal dispersion, and true solution. In this particular chapter, we have to discuss true solution in detail. So let's have a look at the definition of true solution, which says that a true solution is defined as the homogeneous mixture of two or more substances. Now when I say the word homogeneous, homogeneous implies uniformity of appearance throughout the mixture. Now when I say homogeneous, there is one more word which keeps on repeating, that is heterogeneous. And what do you mean by heterogeneous? In this case, the mixtures or heterogeneous solutions are the mixtures where two or more phases are present. That's a basic difference between homogeneous and heterogeneous. Let's continue with the definition. We have said that a true solution is defined as the homogeneous mixture of two or more substances where the composition of which is not fixed. The composition of the particle present in the true solution is not fixed, and it also may be varied within certain limits, and that's the precise definition of true solution. A true solution is defined as a homogeneous mixture of two or more substances, the composition of which is not fixed and may be varied within certain limits. When I talk about the entire definition of true solution, let us catch the word substances. These substances which are present in the true solutions are of two types, of which the first one is called as a solvent and the second is called as a solute. If I need to define solvent, then here they are the one which are going to constitute the larger part of the solution. And if I talk about solute, then it is exactly opposite. It constitutes the smaller part of the solution, and that's precisely what exactly is solvent and solute. Now when we talk about this solvent and solute, there is definitely some interaction. And when I talk about the interaction of solvent molecules with the solute particle to form an aggregate, that entire interaction is called as solvation. And when the solvent is water, then this solvation is becoming a very specific name that's called as hydration, or it is also called as aquation. So when the solvent is water, the process of solvation is called as hydration or aquation. Let us talk about something more interesting, in which cases the extent of interaction can become very high. Then the extent to which the solute dissolves depends upon the nature of solute and the nature of solvent. Likewise, we have a phrase called as like dissolves like. It means what? That polar solute should be dissolved in polar solvent, like NaCl in water, because water is universal polar solvent and it is having a very high dielectric constant. And the other example to prove this will be non-polar solute dissolves in non-polar solvent. The example is iodine in CCl4. Correct? So that's what we have for this particular module. Thank you so much.